the final type of variation that we want to look at is combined variation. In other words, what if something varies directly with one variable, but inversely with another? I'll refer you to the final definition in this section. So our situation is this. We have students in Professor Acosta's class working in groups. In one section of the class, the groups are of 3 students, and in another section, students work in groups of 4. If we assume that the number of minutes it takes to solve a set of problems varies directly with the number of problems assigned, and inversely with the number of students in a group, then we're also told that it takes 32 minutes for a group of 3 students to solve a set of 11 problems. And finally, we're asked, how long will it take a group of 4 students to solve 17 similar problems? So that's a lot to take in, for sure. What we know is that we have combined variation. We're told that the number of minutes, we could call that m, varies directly with the number of problems assigned, right? The more problems you have, the longer it should take you to solve them. So we could say this is k times the number of problems. Now, if there are a lot of students working on the problems, those problems are going to get solved faster. So we're told that this also varies, m also varies inversely with the number of students. And so that is how we would set up our variation equation. So we are additionally told that it takes 32 minutes. So we have m equals 32. For a group of 3 students, so s equals 3, to solve a set of 11 problems. So p equals 11. Alright, what that gets us, if we combine all 4 of those known factors, is 32 is equal to k times p, which we know is 11 in this case, divided by s, which we know is 3. So that will get us an equation that only involves k, the constant of variation. Now, if we multiply both sides of our equation by the reciprocal, 3 over 11, we can cancel the 11 and the 3 and be left with k. So k is equal to 3 over 11 times 32, which is approximately 8.73. Okay, so our constant of variation we now know, which means we can set up our model. Our model in this case we know has the structure m equals kp divided by s. And now we know k, so k, 8.73, p, we know, or we do not know in general, over s will generate m. Alternately, you could say m equals 8.73 p over s. So let's take stock of where we are. We've got a model, and we're given this question. We're told about the first scenario involving groups of 3 students solving sets of 11 problems. Then we're asked how many minutes it'll take for a group of 4 students to solve 17 similar problems. So what do we know at this point? Well, there's our model. But what's different? We have now groups of 4, so the number of students has become 4. We're also told that they're not solving 11 problems, they're solving 17. So the number of problems would be 17. And the question itself is how many minutes it will take. So M is what we don't know yet. But we have this model that should spit M out for us. We have 8.73 times P, 17, divided by 4. That is what M will be equal to. If you plug that into a calculator, you get about 37.1. And remember our units, this is minutes. Okay, in other words, it takes 4 students 37.1 minutes, abbreviate that to minutes, to min, to solve 17 problems. That's our conclusion. And those are all of our types of variation. So we have seen direct variation, both ordinary and involving powers. We've seen inverse variation, again, both the ordinary inverse variation and one involving powers. We've seen joint variation, and finally we've seen combined variation. So go give those homework problems a try, and bring any questions you have to class.